This is 5.4a, elementary algebra, addition and subtraction of polynomials. And you'll find that a lot of this stuff in this section should come pretty easy and should be somewhat familiar because we've talked about some of it before. In fact, the very first term here that we're going to talk about is a polynomial. Now, if you remember right, in the last section we talked about poly, meaning many. So many nomials, many terms. So anytime I have more than one term, like right there's one term, that's a monomial. If I put a plus 3 on that, I just made it into a polynomial because I have more than one monomial. Poly meaning many. Now there are some specific names. So when you have two terms, like I do here, it's called a binomial. And when I have three terms, like 15x squared y plus 21xy squared minus 7. Okay, and this one I've got 1, 2, 3 terms. So when you have three terms, what do you think that's called? Trinomial. And those are basically the three we're going to deal with. The monomial, the binomial, the trinomial, and then everything else is a polynomial. And I have a tendency to call most of them just polynomials just because they all fit into that category. But the second definition there is the degree of a polynomial. Now the degree of a polynomial, according to their definition, is the degree of the leading term once the polynomial is written in standard form. So, for example, 2x plus 3x to the fifth plus 1. That is not written in standard form. Standard form says that we put the largest degree of the polynomial first, or largest degree of the term, and then the second largest, and then the third largest, etc. So this one, the degree of this term right here is 5. So we're going to put it first because there isn't anything else with a degree of 5. This one has a degree of 1 because the exponent on the x is a 1. And then the 1 has 0 degree, so we put it last. So we put it in that order, and that's called the standard form. Once it's in that form, the degree of the first term is the degree of the entire polynomial. So the degree of that whole polynomial is 5. Okay, so we don't do a whole lot with degree of polynomials at this point, but it is good to be familiar with what's going on here. Let's look at example 1 here, and they're asking us to write this in standard form and then state the degree of the polynomial and the leading coefficient. Okay, so what we're going to do here is look at the degree. The degree here is 4, the degree of that is 2, the degree of that is 1, the degree of that is 0. So we just put them in that order, 4, 2, 1, 0. So 3x to the fourth, and we go then to the next one, but we have to carry the sign with it, plus 2x minus 5. Okay, so there it is in standard form. The degree of the polynomial is the first term's exponent, and then the leading coefficient is the 3 right here. The coefficient is the number in the first term that we're talking about there. Okay? So that's pretty much it. The next section has to do with evaluating polynomials. And evaluating polynomials means that they're going to give you a polynomial, and they're going to give you a value for x, and they're going to want you to plug that x in there and get an answer. All right, so let's go ahead and do that. 3, put a 5 in there for x, and I always put it in parentheses, just makes it easier, helps me to know I'm going to do that first. So 75 plus 1 is 76. Okay, so let's jump over to example 2. They give us 3x squared minus 5x plus 4. And they're telling us x is equal to negative 2. So wherever we see an x, we're going to put a negative 2 in there. And again, I like to use parentheses. Makes life a lot better. So we do that first, and because the negative is in the parentheses, we square the negative 2. So negative 2 times negative 2 is positive 4. Minus 5 times negative 2 is negative 10 plus 4. You could have said that negative 5 times negative 2 is positive 10, because here you've got two negatives there, so those are going to change. So now we have 12 plus 10 plus 4 equals 26. And we're done with example 2. All right, so let's look at some addition here, and this is where we get into example number 3. And the addition of polynomials is based on previous knowledge that we've done before. If you remember right, when you add terms, you can only add terms that have the same variable and the same exponent on the variable. Okay? If they're not the same, you can't combine. So let's look at a big one like example 3. Gives me 2x squared minus 5x plus 3 plus the quantity 4x squared plus 7x minus 8. All right, so because there's a plus sign here, we can take the parentheses off and it doesn't do anything. If this were a minus sign, we couldn't take this set of parentheses off until we changed the sign of everything inside. Then we can take it off. All right, so we've got 2x squared minus 5x plus 3. All right, so I'm just going to underline in green like terms. That one's like, and that one's like. They both have x's, and both of those x's are squared. All right, and we're going to box in yellow the next set, including the sign in front. Okay, so I can combine those. And then I'm going to circle in green the regular old numbers there. Okay, so now I know I'm just going to combine what's underlined in green. And remember, when you add like terms, just the numbers are added. The x squared doesn't change at all. So that's done, and that's done. Now we'll do the negative 5x plus the 7x, and we get plus 2x. And those are done. Those are done. And now we have plus 3 minus 8, which is minus 5. Okay, so not only is it now simplified, but it's in the correct order. It's in standard form, with the biggest exponent here, the next one here, and no exponent there. So that is how you do example number 3. All right, so let's jump to example 4. And example 4 gives me an x squared plus 3x, and it says add that and 2x plus 6. So I'm going to start out because it said take this whole thing and add it to this whole thing. Again, because of this plus sign, I can take my parentheses off without any problem. Okay, you can always take this first parenthesis off because there's no sign in front of here, so you just drop the parentheses. But this one, you can only take them off if this is a plus sign. If that's a minus sign, then everything changes. This changes to a minus 2x, this changes to a minus 6. Then you can take the parentheses off. So let's combine like terms. There's nothing to combine that with, so it stays by itself. Plus 3x plus 2x. And then I got a 6 at the end. And we're done. And it's in standard form. Okay? Doesn't always end up in standard form, but in the cases that we've worked with so far, they have. All right, let's jump to example 5. It says find the opposite of this. So when you find the opposite of that, what that means is it means put that in parentheses and make it negative. That's the opposite. The opposite of positive is negative. The opposite of negative is positive. And in order to simplify that, we need to take the parentheses off. Well, what have we learned about a negative in front of the parentheses? You can take the parentheses off if you change the sign of everything in the parentheses. And you're done. Okay? That's all there is to finding the opposite. All right, take us down to example 6. And we're going to continue with this negative sign on the outside of the parenthesis. Alright, so notice there's no sign in front of here, so it's a plus sign, which means there's no problem taking this off. Nothing ever changes unless there's a negative in front of that parenthesis, like there is here. So, take the parentheses off, make everything its opposite. Okay, now we're going to combine. So we're going to combine this with this. Okay, so 3x squared minus x squared, remember it's just 3 minus 1, so it's 2x squared. So those are done. Now let's do a plus x and a minus 2x. So that gives me a minus 1x, and those are done. And a positive 4 minus 3 is a positive 1. Alright, and we really don't even need this 1 in front of the x because there's already there's only one x there, so why label it again that there's 1 there when you can see that there's 1. Okay, so we end up that for an answer, and we're good to go. So let's jump to example number 7, and then we'll go on with another video as we continue on. So example 7, it says, subtract negative 4x squared plus 5x minus 7 from x squared minus x minus 1. So we're subtracting negative 4x squared plus 5x minus 7. Okay? So that's what it looks like. Now another way you could say it, let's just use some real simple numbers. Subtract 7 from 12. What does that mean? Subtract 7 from 12. That means we're going to take 7 away from 12. Okay? And that's what we did in this problem above. Only there's trinomials there. Subtract this number from this number. Okay? So we've got a minus sign there. That means in order to take this parenthesis off, we have to change the sign of everything in here. So we can take this sign, or these parentheses off. Almost always can do that. We're going to change that to a plus, that to a minus, and that to a plus. Now I can start combining that and that. Okay, so those go away. Now I can combine this negative x with negative 5x. And then I can combine negative 7, or negative 1 with positive 7. And I get that for an answer. And one of the things you want to do is make sure it's in standard form, which it is. Highest degree there, the next highest there, and the 0 goes at the end. 0 degree on 6. And you're done with that. Alright, so that's it for example 7. I'm going to quit this video and go into just the problem set. I think that's all we've got left.